This video is going to have a look at how to use the completing the square method to complete a factorization. So by the end of the video, you'll be able to factorize by completing the square. So we can use this method when we have a quadratic expression that has an x squared plus bx plus c. So in the previous video, we looked at expressions that had x squared plus bx, and we looked at how we can complete the square using those expressions. We are going to follow the same process here. However, when we complete the square, on the end we are going to have a plus c value or a minus c value depending on what the operation is in the original expression on the end of our expression where we've completed the square. When we complete the square, we're going to take our b value and divide it by 2. And it is going to be x plus b over 2 squared minus b over 2 squared, and then plus c on the end. So you recognize this first part is the same as what we were doing when we were completing the square, when we had two expressions in the previous video. And this time we got our plus c on the end. We'll be able to use this expression after we've completed the square to then be able to simplify and then write in factorized form. So let's have a look at how we can complete this process. So I want to factorize the expression of x squared minus 10x plus 4. And my first step is going to be to complete the square. So to complete the square, I focus on my x squared minus 10x and I identify my b value, which is going to be 10. So I take that b value and I start completing my square. So it's going to be x minus 10 divided by 2, and then in brackets squared, minus 10 divided by 2 squared, and then I'm going to put my plus 4 from the original expression on the end. So now that I've completed the square, I can go ahead and simplify the expression. So 10 divided by 2 is going to be 5. So I can, instead of writing 10 over 2, I can just write 5. So it'll be x minus 5 squared minus 25, because 10 divided by 2 is 5, 5 squared is 25, plus 4. So that can be simplified a little bit further. So x minus 5 squared minus 21. So now that I've got it in this simplified form, what I can do is I can write in factorized form. And I'm going to write it in factorized form using the same format as the difference of two squares. So it's going to be like a plus b and then a minus b. So using my simplified expression, my a value is going to be x minus 5 and my b value is going to be 21. Now you remember from when we looked at the difference of squares, we need to square root both of those values. So we can square root x minus 5 squared and it's going to become x minus 5, but we can't square root 21. So what we are going to do is we will just write it as the square root of 21. And if you don't remember how we complete that process, go back and have a look at the video and the information on factorizing using the difference of two squares. So when we write it, we're going to write our a value first. So our x minus 5, and then plus the square root of 21 in our first set of brackets, and then x minus 5 minus the square root of 21 in our second set of brackets. And that is the factorized answer for x squared minus 10x plus 4. When we factorize it, it is going to be x minus 5 plus the square root of 21, x minus 5 minus the square root of 21. So let's have a look at a second example. And we've got x squared plus 6x plus 2. So identifying my b value as 6. So I'm going to substitute in 6 divided by 2. So it's going to be x plus 6 divided by 2 in brackets squared. Then I'm going to subtract 6 divided by 2 in brackets squared, and then put my plus 2 on the end. So now I can continue by simplifying that expression. 6 divided by 2 is going to be 3. So x plus 3 squared minus 9, because 6 divided by 2 is 3. 3 squared is 9. So minus 9 plus 2. Now minus 9 plus 2 is going to equal to negative 7. So it's going to be x plus 3 squared and then minus 7. So now that I've simplified that expression, I can write it in factorized form using the format of a plus b, a minus b. My a value is going to be x plus 3 squared. My b value is going to be 7. So I can square root my a value to get x plus 3, can't square root my b value, so I will use the square root of 7. So when I write it in factorized form, it is going to be x plus 3 plus the square root of 7, x plus 3 minus the square root of 7. And that is my factorized answer for x squared plus 6x plus 2. So let's have a look at a third example, where this time it is going to be x squared minus 5x plus 1. So here we've got an odd number. We've got a 5 value for our b. So we'll have a look and see how that's going to impact on our factorization process. So completing the square, my b value is going to be 5. So it's going to be x minus 5 over 2 in brackets squared minus 5 divided by 2 in brackets squared, and then plus 1 on the end. So when I go ahead to simplify that expression, I can't simplify 5 over 2 without making it into a decimal. So that is going to stay the same as x minus 5 over 2 in brackets squared. I can square my 5 divided by 2 by squaring both the 5 and the 2. So it is going to become minus 25 over 4. And then I still need to put my plus 1 on the end. Now, instead of putting plus 1 on the end, I'm going to convert that into a fraction with a denominator of 4. So that is going to be plus 4 over 4, because we know that 4 divided by 4 is equal to 1. So I multiplied 1 by 4 to get my numerator. So now I've got a set of fractions that have the same denominator. I can go ahead and simplify that. So x minus 5 over 2 squared, and then minus 25 over 4 plus 4 over 4 is going to equal minus 21 over 4. And that is why when we write our 1, when we go ahead and simplify, we write it as a fraction with a denominator of 4, because it allows us then to be able to simplify and add our fractions together. If you're not confident on converting 1 into a fraction of 4 over 4, you can just use your calculator. You can put in minus 25 divided by 4 plus 1, and it will tell you that the answer is negative 21 divided by 4. So if you're not confident, use your calculator to be able to help you. So now we've got it in a simplified form. We can write it in factorized form. So our a value is going to be x minus 5 over 2 squared. Our b value is going to be 21 over 4. So when we write it in factorized form, it is going to be x minus 5 over 2 plus the square root of 21 over 2, x minus 5 over 2, subtract the square root of 21 over 2. Now, in case you were wondering how we got the square root of 21 over 2, what we would do is we would square root the whole term of 21 over 4. We can break that down and we can apply the square root to both the numerator and the denominator. So that is going to equal to the square root of 21 divided by the square root of 4. Now, because we know the square root of 4 is 2, we can write it as the square root of 21 divided by 2. So that gives the most simplified answer when we're writing it in factorized form. So the factorized answer of x squared minus 5x plus 1 is going to equal x minus 5 divided by 2 plus the square root of 21 over 2 in the first set of brackets, and then in the second set of brackets, x minus 5 over 2, subtract the square root of 21 divided by 2. So let's have a look at a fourth example. Again, our b value is going to be an odd number. So we want to factorize the expression of x squared plus 3x subtract 2. So we'll start off by completing the square, and it is going to be x minus 3 divided by 2 in brackets squared, minus 3 divided by 2 in brackets squared, and then minus 2 onto the end. So going ahead and simplifying, my first set of brackets is going to stay the same because I cannot simplify 3 divided by 2 without making it a decimal. So x minus 3 over 2 squared. Then I'm going to simplify 3 divided by 2 squared by squaring both my numbers. So it is going to be 9 over 4. And then I'm going to subtract 8 over 4. Because again, I want to be converting that number into a fraction with the denominator of 4. So 2 times 4 is 8. So 8 over 4. So going ahead and simplifying, it is going to be x minus 3 over 2 squared. And then minus 9 over 4 minus 8 over 4 is going to equal to negative 17 over 4. So now that I've got it in a simplified expression, I can go ahead and factorize. and my a value is going to be x divided by 3 over 2 squared. My b value is 17 over 4. So writing it in factorized form is going to be x minus 3 over 2 plus the square root of 17 over 2 in the first set of brackets. In the second set of brackets, it is going to be x minus 3 over 2, subtract the square root of 17 over 2. And again, our 17 over 4, when we square root that, we apply the square root to both the 17 and the 4. Square root of 4 is 2, so it becomes the square root of 17 divided by 2. So there are some examples of how do we complete a factorization by completing the square. As this is the form of factorization that students normally struggle with the most, so make sure we're spending some time practicing the questions, checking your solutions, and letting your maths teacher know if you have any questions or need any extra help.